Hello student, today I am going to discuss limiting reagent. What is actually limiting reagent? I will discuss now. Many a time the reactions are carried out when the reactant are not present in the amounts as required by balanced chemical reaction. In such situation, one reactant is in the excess over the other. The reactant which is present in the lesser amount gets consumed after some times, and after that no further reaction takes place, whatever be the amount of the other reactant present. Hence, the reactant which gets consumed limits the amount of product formed and is therefore called the limiting reagent. Now, one example I am giving you. Suppose nitrogen and hydrogen both are reacting and giving the product ammonia. N2 plus 3H2, that is giving 2NH3. Nitrogen and ammonia, actually they will react in a fixed ratio, N2 plus 3H2, 1 mole of N2 and 3 mole of hydrogen. Both will react, means ratio is 1:3, and after the reaction it will give 2 mole ammonia. Then here 1 mole nitrogen and 3 mole hydrogen is required, means 1:3 is required to give the 2 mole of ammonia. Then here suppose nitrogen is in less quantity and hydrogen is in more quantity. Then what will happen? Suppose hydrogen is in excess. Hydrogen is in excess and nitrogen is in less quantity. Then nitrogen will finish first and now it will stop formation of ammonia. Then here nitrogen is limiting reagent. In a reverse case, suppose nitrogen is in excess and hydrogen is in a short supply, means less. Then again whatever hydrogen is there, that will react with nitrogen and again reaction will stop. Even nitrogen is present but hydrogen is not there. Hence now you can tell hydrogen is limiting reagent. I think now you have understood what is the limiting reagent. Now I am going to discuss very important terms or concept, you can tell, not the term, that is a reaction in solutions. Reactions in solution, how you know that all reactions, almost all reaction takes place in the solution form. Then now the concentration of a solution or the amount of substance present in the given volume can be expressed in many ways. I will discuss one by one. Here, meaning of concentration, you should understand moles per liter, that is called concentration. Moles of solute present in 1 liter solution is called concentration, also called as strength. Then now how will you represent the concentration? Then first way to represent the concentration is mass percent. also known as weight percent. Then what is the mass percent? Then mass percent or weight percent, that is a W divided by W, weight by weight. What is this? Then first you should understand the formula. Mass percent is equal to mass of solute divided by mass of solution into 100, upside 100. Then this is the formula, mass of solute divided by mass of solution into 100. One example I will give you. Suppose 2 gram of substance A is dissolved in 18 gram of water. Then total became 2 plus 18, 20 gram. Then in 20 gram, 2 gram of A is present. Then what is the percentage of mass percentage of A? Then 2 divided by 20. 2 divided by 20. That is in the term of formula you can tell masses of A divided by masses of solution upside 100 into 100. Then now it became 2 gram divided by 2 plus 18 gram. 2 gram of A and 18 gram of water, total 20 gram into 100. Then mass percentage of A will be 2 divided by 20, that is equal to 10%. Then this is called mass percentage or weight percentage. Like that way, other terms are also there. You should understand only here. Volume by volume. Volume by volume also you can say for concentration this term is also used, volume by volume. Suppose 10 ml alcohol is dissolved in 100 ml water. Then same way now you can consider the percentage. 10 divided by 100, 10 upside 100. That is called volume by volume. This term is used when both are liquid. Now one more term you can tell, weight divided by volume. Weight divided by volume. Suppose you have taken 10 gram of sugar and you have dissolved in 100 ml water. Then now what will be this percentage? Then here you can tell now 10 ml is present in 100 ml. Then simply 10%. Correct? Then this I told you that mass percentage, and after that this percentage term you can tell in the term of mass, in the term of volume, in terms of you can say weight. Weight means W by W, second V by V, and third W upon V, weight by volume. Okay, this I have discussed. Now main you can say term of concentration now I am telling. One measure I told you, in that there was three classes, W by W, V by V, and W upon V, means weight by volume. Now here again before going to the next I want to tell you weight by weight. That is the only percentage, no gram, no milliliter, nothing. Second term both are volume. Hence again volume term will cancel, hence no unit, only percentage. And third one weight by volume. Then there you can tell this, because that you are telling one is in weight, other is in ml. then 10%, that is 10 gram is present in 100 ml. Correct? Then per 100 ml W gram. Like that way you can tell. Or if it is present in liter also W gram per liter. W gram per liter. Like that way also concentration is expressed per liter, weight per liter. Now come to the other important terms, that is the mole fraction. Mole fraction, one term is there, and second term is there, I will discuss, that is the molarity, and third important term, that is the molality, Lity. First one was molarity and second term is molality. Molarity is expressed by capital M and molality is expressed by a small m. Then now one by one I will discuss. But now come to the mole fraction. What is the mole fraction? That you try to understand. It is the ratio of number of moles of particular component to the total number of moles of the solution. If a substance A dissolves in substance B and their number of moles are N1, Na and Nb, a small n and a small Na, small na, A and other Nb, a small nb respectively, then the mole fraction of A and B are given as follows. Mole fraction of A, actually A and B you both you have mixed. Then Na and Nb is telling about the number of moles of A and Nb is telling number of moles of B. Then now mole fraction of A is equal to number of moles of A divided by total number of moles. Means number of moles of A divided by number of moles of solution. That is, you can tell Na divided by Na plus Nb. Like that way, mole fraction of B, that is the number of moles of B divided by total number of moles of in a solution. That is the Nb divided by Na plus Nb. This I have told about the mole fraction. Generally in solution, two things are required, solute plus solvent. Then mole fraction of solute, and you can calculate mole fraction of solute as well as mole fraction of solvent. Then suppose you want to calculate mole fraction of solute, then solute you keep upside, number of solute will be upside divided by total. Divided by total, number of solute plus number of solvent. Both you add, then becomes solution. Mean in solution, total number of moles of solute and solvent. Like that way, if you want to calculate number of moles of solvent, then keep upside number of moles of solvent divided by number of solute plus number of solvent. This will tell you about the number of solvent. Number of solvent, the mole fraction of number of solvent. Like this way, you can calculate the mole fraction of solute as well as mole fraction of solvent. Now I am going to discuss about the molarity. Molarity, what is the molarity? Actually, all terms are very easy and conceptual. Once you will understand, you will not forget. Here, molarity, R-I-T-Y, molarity, capital M. Then number of moles present per liter of the solution, that is called molarity, or you can tell it is the most widely used unit and is denoted by the capital M. It is defined as the number of moles of the solute in 1 liter of the solution. Then mathematically you can represent molarity is equal to number of moles of solute divided by volume of solution in a liter. Now I will give one example. Now suppose 4 gram sodium hydroxide is dissolved in 250 milliliter of 250 milliliter of water. 4 gram sodium hydroxide, suppose it is dissolved in 250 ml water. Now you have to calculate what its molarity. Then I told you, here you should know, again so many times I told you, again I am telling you that mole is equal to weight divided by molecular mass. Then here 2 gram is dissolved. Okay, you take 2 gram or 4 gram over. Suppose 4 gram is dissolved in 250 ml water. Then in 1 liter how much? Then in 1 liter it will become 16 gram, because in 250 4 gram is there. Then in 1 liter, that is 1000 ml, it will be 16 gram. 16 gram. Then now 16 gram per liter is there, gram per liter. Then now this 16 gram NaOH now we convert into the mole. Then now where is it? 16 divided by 40. 16 gram divided by 40. 40 is the molecular mass of NaOH. That is a 23 plus 16 plus 1. NaOH 40. Then 16 divided by 40. 16 gram sodium hydroxide means how many moles of NaOH? Then 16 divided by 40. Then this mole is dissolved in 1 liter. After solving this, means 16 divided by 40, it will come 0.4. Then this 0.4 mole is present in 1 liter. Then its molarity is 0.4 m. Now I am going to discuss molality, L-I-T-Y, a small m, molality, a small m. Here again it is the same way, only unit will change. Actually molarity as capital M, you have seen it was in gram per liter. Here both will be in gram, solute will be in gram and solvent will be in kg. Okay. Then here what is actually this definition? Then molality may be defined as the number of moles of solute. Here again moles is there, but per kg. Moles per kg, not in gram, moles. You have converted whatever weight is there in moles. Then moles per kg, that is called molality, a small m. Then you can define it as the number of moles of solute present in 1 kg of solvent. Okay. Hence mathematically you can write molality, a small m, in bracket you can write is equal to number of moles of solute divided by mass of solvent in kg. Then its calculation is again same way what I have discussed now. If it is in gram, then gram solute is in gram, convert in its mole. How many moles are there? Gram weight divided by mole, that is the weight divided by molecular mass, that is equal to mole. I have discussed. Then that gram is converted into mole, then how many moles are present per kg, that is the molality. Then molarity can be calculated, and I will tell you now next term, that is the normality. Normality, capital N. It is very, very important and full of concept. So many numericals is asked based on normality. Then here normality, what is the normality? The normality is actually number of equivalent dissolved per liter. Very simple way. Number of equivalents of moles or substance dissolved per liter, that is called normality. Number of equivalent. Now what is the equivalent? That is again very, very important concept. Then equivalent means equivalent of generally in chemistry, in solution, acid base reaction will be there. Hence number of moles, number of equivalent in terms of acid. For acid, how will you will come to know equivalent? Then for any acid, particularly ionic acid I am talking about, then equivalent of an acid like HCl, that will be the molecular mass of HCl divided by basicity, means replaceable hydrogen, because if acid is present in water, then it will dissociate H ion. That is how many H is present in the acid, that is called basicity. Then equivalent you can say acid equivalent, that is you can tell equivalent for acid, that is the molecular mass of the acid divided by replaceable hydrogen ion, also called basicity. As for example, HCl is there, then HCl in water, it will replace only one hydrogen. Then molecular mass of HCl, that is the 36.5. How? Then 1 H plus 1 Cl, then 1 plus 35.5, that is 36.5. Then this is the molecular mass. Then 36.5 divided by 1, because only one hydrogen is there. Then its equivalent mass. Equivalent mass will be 36.5 divided by 1, that is a 36.5 only. Like that way, equivalent mass of base you can calculate in the same way. Molecular mass of the base divided by acidity. Acidity means here number of replaceable OH ion. As for example, NOH, it has only one OH. In water, it will replace only one OH. Hence, equivalent mass of NOH, that is equal to molecular mass of base, means molecular mass of NOH divided by number of OH ion replaced, means replaceable OH ion, that is called acidity. For the base, the term S you have to divide by acidity, and for the acid you have to divide by the term basicity. Just reverse way. For acidity you divide by basicity, for the base you divide by acidity. Molecular mass is common. Then for the molecular mass of base, means molecular equivalent mass of base is equal to molecular mass of a base divided by replaceable OH ion or acidity of base. Here in case of NOH, molecular mass is 40, 40 divided by 1 because only one OH is there in NOH. Then 40 divided by 1, that is only 40. Means here molecular mass and equivalent mass both are same in case of NOH. In case of HCl also 36.5 divided by 1, that is 36.5 only. Hence in this case also molecular mass and equivalent mass both are equal. Now another example I am giving you. Suppose acid is H2SO4. Then here 2 hydrogen is replaceable. Then molecular mass of H2SO4, that is the 98. Then 98 divided by 2, that is 49. If we will consider HNO3, then again molecular mass of HNO3, you add H plus NO3 all. HNO3, 1 H is there, 1 nitrogen is there, 3 oxygen is there, put the atomic mass. That is the molecular mass. Then molecular mass divided by only 1 H is there. Then molecular mass divided by 1. In this case also molecular mass and equivalent mass is equal. But if you take H3PO4, then here 3 replaceable hydrogen is there. H3PO4, phosphoric acid. Then molecular mass of H3PO4 divided by 3. Then you will get equivalent mass of phosphoric acid. Then like that way, base if you will calculate, as for example, you want to calculate calcium hydroxide, equivalent mass of calcium hydroxide, CaOH whole 2. There 2 OH is there. CaOH whole 2, 2 OH is there, it will give in solution 2 OH. Then here molecular mass of calcium hydroxide divided by 2. Then calcium hydroxide molecular mass, how will calculate? Ca plus 2 OH. Then Ca 40 plus 2 into OH. O 16 plus 1 17, 17 into 2 34. Then 40 plus 34, 74 divided by 2. That will be the equivalent mass of calcium hydroxide. Same way aluminum hydroxide. Then here replaceable hydrogen is 3. Hence molecular mass of aluminum hydroxide divided by 3. Then that is called equivalent mass of aluminum hydroxide. Then now I have told you about the equivalent mass. Then this is actually a number 1 equivalent, 2 equivalent, 3 equivalent. As for example 36.5 HCl means 1 equivalent. 40 gram of NOH means 1 equivalent NOH. And like that way calcium hydroxide you will calculate, whatever value will come, that is a 1 equivalent. Aluminum hydroxide, whatever value is coming, that is the 1 equivalent. Then if that is called number of equivalent, as for example suppose 80 gram NOH is present in 1 liter, 80 gram, then 2 equivalent is present. 2 equivalent is present in 1 liter. Hence solution will be called 2N. If only 40 gram is present in 1 liter, then solution is called 1N. Like that way 40 divided by 10 means 4 gram is present, then N upon 10. Normality is N upon 10 means 0.1. Like that way in case of acid also same way you can calculate. 36.5 gram HCl is present in 1 liter, then 1N. If 3.65 is present means 1/10, then normality will be N by 10 means 0.1 N. If we can say 36.5 into 2, 73 gram is present in 1 liter, then 2 NHCl. Like that way you can know the normality. Now next term, that is the last term I am going to discuss, that is the formality. F, capital F, it is denoted by capital F. Actually, formality term is less used. This is only for ionic compound like NaCl, KCl. This term is used. Any for salt also, generally you can tell for salt, that because all salt will exist in the term of positive and negative ion, cation and anion. Then for the ionic term, formality is used. Then it is just like molarity term. That formula weight you add, just like molecular mass we were adding all, here also you add. As for example, KCl, molecular mass of K plus molecular mass of K plus not molecular, atomic mass of K plus atomic mass of Cl, add it. As for example, K 39, chlorine 35.5, add both.